Hello everyone and welcome in today's video about the electronic structure. During this class, we'll be talking about the electron shells, the subshells and the orbitals. As defined before, an atom is composed from a nucleus which is surrounded by the electrons. Okay, so from this image here you can see that in this sodium atom we have the nucleus which are surrounded by the electrons in different energy levels. Actually, those energy levels are called the principal quantum shells, and they are numbered according to how far they are from the nucleus, which means by the numbers 1, 2, 3, and so on. The first energy level, or the first principal quantum shell, can hold up to 2 electrons, as you can see here. The second one can hold up to 8 electrons, the third one up to 18, and the fourth one up to 32 electrons. And actually, the arrangement of electrons in an atom is called its electronic structure or the electronic configuration. And we will be taking a look about this by details in the next lesson. The figure here is showing the principal quantum shells numbered from 1 until 4, as you can see here. They are arranged here by increasing the energy from number 1 to number 4. Those principal quantum shells are split into subshells, which are given the letters S, P, D, and F. And actually you will find that the elements with more than 57 electrons have also an F subshell, which means that those with less than 57 electrons, they will be having only S, P, and D subshells. As you can see here, there is an overlap here between the 4s and 3d. This is due to the fact that the 3d subshell has a slightly higher energy than 4s. So, while filling the subshells, we will start with the 4s, then followed by the 3d. And now we will be talking about the orbitals. By definition, an orbital is a region from space around the nucleus of an atom that can be occupied by one or two electrons. And actually, this is where we can find exactly the electron. This is where the high probability of finding an electron is. Okay? As you can see here in the image, the s orbitals and the p orbitals, which are represented in this stage. So the s orbital has a spherical shape, and it's normally drawn as a simple circle. And for the p orbitals, they have a shape of, let's say, a dumbbell, and they are normally drawn as what you can see here. And we can distinguish three p orbitals. For the s orbitals, there is only one orbital, and for the p orbital, we can distinguish three, the px, py, and pz orbitals. And we said that an orbital can occupy a maximum of 2 electrons. So the s orbital can occupy a maximum of 2 electrons. The p orbital, which is containing 3 orbitals, px, py, and pz, each one can hold up to 2 electrons. So it will be 3 times 2, which means the p orbital can hold up to 6 electrons. And we can find 5d orbitals, which means that they can hold up to 10 electrons. And for the f orbitals, we find 7 f orbitals. This means that the f orbitals can hold up of 14 electrons. Actually, here it's worthy to mention that the orbitals in the same subshell, for example, px, py, and pz, have the same energy and they said to be degenerated. So for the principal quantum shells, for example, the principal quantum shell number 2, it's containing the subshells 2s and 2p, which are containing the orbitals. So for the 2s, it's containing the s orbital, which is spherical in shape, and the p subshell is containing 3 orbitals, which are px, py, and pz. This is all for this lesson. I hope it's helpful for you, and thank you for watching.